Hello, and welcome to Building Windows 8 Metro-style casual games using HTML5 and JavaScript. My name is Dave Zbitsky. I am a developer evangelist with Microsoft. I focus on helping developers be as successful as possible across the Microsoft developer platform. So where we're going to focus on today is Windows 8 Metro-style apps, and where I'm going to show you specifically is how you can leverage HTML5 and JavaScript to really create some interesting casual games that I think that'll sell well on the Windows Store. Now, don't worry about if you haven't been exposed to HTML5. Myself, I was a C# XAML guy and still am. For a very long time, I had not touched JavaScript, and the past couple of months have been an eye-opener for me, how powerful this stuff is, and the community that surrounds that. I think you'll be pleasantly surprised as well. If you are a web developer, I think you'll be smiling a lot through this session as you see how easily you can transfer your skills, and you can bring code that you may have already put on the web into a Windows 8 app and to begin selling that on the store. If this is the first time we are meeting, please do not make it the last. I am available online in a ton of different places, so you can contact me on my blog, blogs.msdn.com DaveDev. Please do visit my blog. That's where I'll be posting a lot of these, the code samples. The Space Cadet code itself will be available there, as well as the slides. And you can also hit me up on Twitter at TheDaveDev. If you want to send me an email, it doesn't even have to pertain to what we cover today. david.izbitsky@microsoft.com. I'm always available to help you out with whatever you're working on. So, the way that I've set up the day is we'll start getting everyone on the same page. So this is a 200 level session, and we have a little bit under an hour to go through all this material. So I want to make sure everyone understands HTML5, CSS3, and IE10, because this is really where Microsoft has been doing a lot in that space, and you're going to be able to leverage a lot of those skills. You're going to be able to leverage a lot of the power of that technology in your Metro-style apps. So if you are coming from a C# or a XAML background, an XNA background, and you haven't checked any of that stuff out yet, I think you'll be pleasantly surprised how easy some of that is. And then what we'll do is we'll look at the HTML5 canvas tag specifically. This is the way that we're going to actually be writing to the screen. You can think of this as an immediate mode render engine, a per pixel engine, where we're going to be doing a certain amount of frames every second. And then we're going to look at a game loop. So the way that we typically write games is through an update draw kind of a recursive method that's going through, and you're going to see that pattern come across. And then we'll look into some Windows 8 specifics, and Microsoft makes it very easy through the WinRT APIs to enable touch and to enable things like camera devices and accelerometers. And then we'll end the day with some WinJS controls. So the Windows library for JavaScript, you're going to see how easy this makes some of the more complex JavaScript patterns for you, and to be able to do that in your app. So to start out, any good session, I feel, has to start out with the final product. So I'm going to show you here what we're actually going to be looking at. And again, I'll have this code posted online, so don't feel like you need to go through, but please, if you're going to watch the recording later on, feel free to move along as I go through this code in your own IDE. So let's go ahead and run this. So what you are seeing now is a full screen Metro style app. You can see I've got a version number down here, I've got a title up here, I've got a button to play, I could easily add settings. I've got kind of this scrolling star field in the back, which is an HTML5 canvas. If I right click, or if I'm on a touch device, if I swipe from the top or bottom, I'll get my app bar. So I have the ability to go to the main menu, I have the ability to enter my cadet name, as well as take a photo. And we're going to cover accessing the camera in a little bit. So if I hit play, you'll see I immediately go into the game mode. I've got a score at the top left, the level I'm on, the name we just entered, and my Space Cadet picture. Now, as I hit different scores, so once I get to 1500, you're going to see a gravity pulse comes across, which you can see right there. And then if I come over and go to menu, we're back at our menus screen. So Let's go ahead and shut that off. Now, I'm going to break apart each of those pieces, and I'm going to show you how you can code that within your own app. But that's really what we're looking at as far as a little 2D shooter sample. So when I talk Windows 8 and I talk JavaScript, there's been some confusion around what's a desktop app, what's a Metro-style app, how do I get involved with the new stuff, what skills am I actually leveraging. So I thought it was important to break that out a little bit here. What you see over on the right is the development that we do today. So, for example, on a Windows 7 machine, if we're using HTML and JavaScript, we're typically targeting the web. So we're doing something, and Internet Explorer is rendering that. We could also be using C and C++, targeting the Win32 API. And if you're a .NET developer, you're most likely using C# or VB.NET, and you're calling into the .NET framework. And I include Silverlight and WPF as part of that. So when we talk about JavaScript and HTML in a Metro-style app, we're really looking at that same underlying JavaScript engine, which we codenamed Chakra. And so that's going to be your controller level. Just like C# would have been your controller level if you're in the C# XAML space, you'll be using that for all of your code behind. And then your layout engine, where you're going to go ahead and you're going to style things and you're building all of your UI elements, that's going to be done in HTML and CSS. So there really is some great overlap here. You're going to be able to take advantage of everything that the web has to offer, all the HTML5 and CSS3 goodness, and then you're going to be able to call down into the new system services layer that we call WinRT, or the Windows runtime. So when I talk about HTML5, it really all began for Microsoft with IE9. So these were some of the W3 standard HTML5 features that we included in the IE9 browser. And if you're writing a Metro-style app casual game, the areas that you're really going to be focused on, first is going to be ECMAScript 5, obviously. That's the latest version of JavaScript. And then we're going to be talking about the HTML5 canvas tag. But what you'll also notice over here is we've got video and audio tags. So these are very easy ways of including music and sound effects in your application, and I'm going to show you how to do that. And then when we're talking about Windows, we're really talking about an entire ecosystem. So this is not one product from one company. This is Windows 8. And if you're going to write an app for Windows 8, you're going to have to think about all of those different screen sizes, all of those different devices, whether it's a tablet or whether it's a desktop, whether it's a 40-inch screen or whether it's a 20-inch screen. Now, the good news is Microsoft has done a lot of thinking around this and really looked at what we've seen on the web with responsive web design and brought that into Metro-style apps. So when we look at things like CSS3 media queries and the ability to rearrange elements on our screen, the ability to pull in different images based on our pixel densities or our specific ranges of screen sizes, you're going to be able to pull in all of those skills that you have from the web into a Metro-style app. Now, we didn't just stop with IE9. So what you're seeing here in the blue are all of the new features in IE10, which are all of the features that you're going to be able to get into Windows 8. And some of the areas, for example, like the pointer events, you're going to see us cover the ability to have both mouse, pen, and touch all work through the same API and not have to worry about where that stuff is coming from. And then you also get a lot of other things in here, like IndexedDB, the ability to go out and to store things in a database kind of way. So some of these features, when we look at CSS3, the ability to do 2D and 3D transforms. So if you're doing something, for example, where you see the scored and you see my current level, a lot of that is done just through CSS3 and where I'm positioning things. I can also transform them. For example, I could rotate them in an X or in a Y axis. I'm going to show you how to do some of those things. You've got built-in transitions and animation. You have a lot of layout, so if you're coming from a XAML background, you can think of the flex box as basically your stack panel. So your grid is basically an MS grid. I have ways of doing rows and columns and doing a really great kind of layout. Think of a setting screen or a gamer high score chart. All of that is going to be very easy to set up on top of your page. And then, of course, we have different types of graphics, so filtering effects, text shadows, and the ability to flow content in multi-columns. All of this is hardware accelerated. So let me go ahead and show you where you can start looking at transforms. And what Microsoft has done is they've set up a site, which I'm going to show you, called the IE Test Drive. So if you go to ie.microsoft.com/test drive, you'll get a bunch of different categories that you can drill down on. So I'm looking at graphics, and this is going to really show off what's new in Windows 8 when it comes to the HTML5 platform. And if you're looking to learn this, if you've never touched any of these things in CSS3, this is an area where you can come in. So I'm going to click on 3D transforms, and then you'll see at the bottom I'm actually building my CSS in real time. So this would be a CSS3 style tag. I can assign this to any HTML element. So this could be assigned to a div, this could be assigned to a button, and I can play around with the effects here. So for example, if I want to rotate this along the y-axis, what you're seeing down at the bottom is I'm doing a perspective transform across the y-axis this many degrees. Now it's CSS3 that's actually doing all of the frames in between for me. I'm simply telling it where I want it to end up. And then if I want to look at things like translate 3D, so for example, I could move this in the z-axis. So you can see it's moving back and forth. I can move it up and down in the y-axis, and then the x-axis, it looks like it's getting closer and farther away from the screen. But all of that is done through a simple translate 3D CSS call. Now, if we go ahead and we look at our Space Cadet game, I want to break the project out for you a little bit, just in case you have not seen a Metro-style app project before. If you're a web developer, this is going to be very, very familiar. And in fact, it follows kind of the MVC pattern of putting all of our JavaScript in a folder, being our controllers, and all of our HTML in folders, and then you're going to have your CSS broken out. Now, I've also got folders here for my resources, so my fonts, my images, and my sounds. Every application is going to start off with a default HTML page. So if we click on default.html and we come up to the top, you're going to see it is indeed HTML5. You've got doc type HTML. And if you are wondering, because the release preview of Windows 8 just released a couple days ago, so you may be on consumer preview and you're saying, wow, what version of Visual Studio is Dave looking? There's color again. So in the release preview, I am proud to announce you're going to see lots of color. You can see it's highlighting. I'm in fact in editing mode. When I go into debug mode, I get another color. All of the buttons at the top you can see are highlighted. So this is my debug start. I have the ability to step over and under. You're going to see all of that used throughout. This happens to be the dark theme. You can also choose a light theme for Visual Studio. Now, what I have here is a bunch of JavaScript references. So this was built in by default. And anytime you see 2 forward slashes, that means it's a shared JavaScript library. What's neat about that is this isn't anything that's a black box. This is, in fact, a JavaScript library. So if I come over here and I click on References, you're going to see the Windows library for JavaScript. I have the ability to see all the CSS that's coming inside of my Metro-style app pre-built, as well as to drill down in the JavaScript. So I recommend this as a great way to start learning some of the features for a Metro-style app. You can actually see how Microsoft wrote the library themselves. So you can come down here, and in fact, if we go ahead and we search for WinJS, you'll see WinJS is a JavaScript function, just like anything else. JavaScript is a functional language, and everything is functions, including WinJS, which you can see right here. So, kind of a neat way to go through and see the underlying framework. And then I've got a default CSS file that came with the project and a default JavaScript file that came with the project. What I've done is I've created my own CSS under Space CSS, and I've added 3 additional JavaScript files here, and we're going to drill into some of those. The rest of this file you can see is very clean, very light. It is basically a bunch of div tags. So on that main screen, when you saw me play, you saw score, level, and then you saw player name and image player, which you can see all here. But those are in fact just HTML elements. You can see I've got an image and I've got a bunch of div tags. Where the actual styling of all that happens is in our CSS. So if I come down here to the CSS folder, again, you're going to have your default. And I've put all of my game CSS under Space CSS. If I open that up, the first thing you're going to see is CSS3 web fonts. So I'm using the @fontface tag here, and you may have noticed it looked very Star Trek-ish, the old series, of course. So what I did for my game is I just did an internet search for royalty-free fonts, and this is one of those fonts that came back. This font is in a TrueType format. To include it in my project, the only thing I needed to do, I created a fonts folder and I dragged that font in, and then I told the font face where the location of that font was. So you can see here, source URL is the CSS3 tag, and I'm saying under fonts, final old. Now, every text element, I can assign the font family to be Final Frontier Old Style. So for example, my score, my player name, all of those are now styled within that font, thanks to the magic of CSS3 web fonts. We also have the ability to place elements on our screen using CSS3. So what you're seeing here is I'm using floats, I'm using positioning. My score, for example, I'm just aligning it to the left and having it 10 pixels over from the left. My version, so I always want my version to be in the very bottom, so you can see bottom 0, right is 0, and position is absolute. So pretty easy kind of layout. You're using all the skills that you already know from the web. It's just CSS3 as a way to define both your fonts and your layout, and then you have the capabilities to do transforms. Now, some of those HTML5 features I mentioned before are going to come very handy inside of our own game. So ECMAScript 5 is something I want to show you first, and one of the newest features in JavaScript is the uses strict method, and I'm going to show you that, as well as audio tags. So how do we use music and sound effects and things like that, as well as adding pointer events. So if we come over here, and we go to the same site, so what you can see here is IE Microsoft.com test drive again. What I'm doing is I'm looking at the new ECMAScript 5 features. So if we come up here and we say we're going to do a new function, you're going to see use strict. Now, if you're coming from a .NET C# background, this is something you've always had. You've always had type checking. If you've ever done JavaScript for the web, and it's been a long time ago, you've probably remembered the pain of misspelling a variable and then having a variable created for you. This is going to save you that headache. And by combining the functionality that you see here with use strict with the power of Visual Studio, you're going to have an application that feels very much like you're used to in all of your other languages. So we're going to get IntelliSense, we're going to get the ability to do breakpoints and drill down and add watches and step in and over and all of that goodness. So just to give you an example here, if I said var and maybe it's app category, and we are a 2D shooter, retro shooter, and then later on by accident, maybe I'm one of those developers that likes starting my variables with a capital, and I rename it to Space Cadet. Normally that would have created a new variable, but if we run this, you'll see we get a variable undefined. So strict mode is your best friend. What's important to remember is that strict mode is its scope is based on the function in which it's in. Now, the good news is, by default, all of the JavaScript files that you're going to use in a Metro style app, it's going to go ahead and it's going to encapsulate all of that in a function for you. So you're going to start off just by using strict. Now let me show you one of the other areas, which is music that we talked about. So if we come down here, you're going to see in order to add that audio that you saw in the menu, it was as simple as saying variable music menu equals new audio, and then I pointed to my sound file. So I have both an MP3 and a WAV file. I'm telling the music to loop, and then if I want to pause or play that music, so let's go ahead and search for this. You'll see later on, if I'm going to go ahead and go back to the menu, I pause my game music, and then I play my regular menu music. What's really cool about the JavaScript space is this community of frameworks that are out there. And one of the frameworks that I've used, if we come over here, is something called Easel.js. So this is from Grant Skinner. They've done Pirates versus Daisies. It's very easy to incorporate this into your own project, and it's free. Metro-style apps have the ability to use those third-party frameworks. For my sounds of my actual spaceships, so the explosions, the rockets, things like that, I used a library called Sound.js. And what Sound.js will do is it'll allow you to create multiple instances of those sound effects and not have to worry about clipping and other things that might happen when you have, 20 or 30 explosions going on your screen at the same time. So what you'll see over here is I have a Sound.js file. Obviously, it's been minimized, the JavaScript file, but I've incorporated it in order to include it in my project. You'll see up here, I just made a reference to Sound.js. And then as I'm instantiating all of my other sound effects, I create an array for these laser effects that I want to use. And then you're going to see soundjs.addBatch. And this is the way that Sound.js queues up all of the sounds that it's going to use. So I've got a red alert, a new level, my gravity pulse. I'm just telling it the source and the number of instances that I want. And then later on, we'll scroll down a little bit. It's because it's not finding it. The actual call is right here. So soundjs.play. So this is what you saw in that batch, the laser sounds, and then I'm going to tell it to interrupt any. So very easy to do both sound effects and music in your apps, easy to do third-party apps, and thanks to the magic of useStrict, it's very easy to bug your app. So one of the things I want to do now is I actually want to put a breakpoint, and I want to show you what that's like. So we're going to go ahead and we're going to have an initialization here. And we're going to go ahead and run this. And the first thing you're going to notice is this feels very much like Visual Studio. So if you've done .NET or any languages before, you can see I've now attached to that process. So even though this is JavaScript and this is running in a web kind of context, you can see here I have the ability to look into my canvas element. I have the ability to step over and step into and add watches and all that other goodness that you're used to when you're doing Visual Studio. And one of the things that you may notice, and I'm going to go over this when we do Canvas, is that the canvas width and height is actually adjusting itself to whatever my screen is. So we talked a little bit about being able to support different screen resolutions. Well, the screen that I'm actually recording this webcast on is running at 1280 by 960. But if I was to run on a bigger screen or a smaller screen, you would see the canvas itself adapt to that. So very easy to pull in CSS3 features, very easy to take advantage of all that HTML5 goodness that's available. Now let's go ahead and look at the actual HTML5 canvas tag. So it used to be that browsers ran on a single thread, so you had your page rendered in software. You had a JavaScript engine that was not running on multiple cores. It was running on a single core. When the Internet Explorer team released IE9, they really looked at how we could take advantage of all of the hardware that's out there in PCs today. So, even netbooks have a graphics processing unit or a GPU. Why don't we have the rendering of that browser done on the GPU versus the CPU? Why don't we have a JavaScript engine that can take advantage of all those multiple cores that we have in these processors today? So that really started with IE9 for Microsoft. And if you want an example of this, I recommend going to cuttherope.ie. You'll be able to play the famous Cut the Rope game inside of a browser. You'll see it's fully hardware accelerated. And then if you hit the top right, there's going to be like a behind the scenes dev tip. If you hit that, they'll tell you what it was like to move from an iOS Objective-C space into the JavaScript world and kind of the performance that they've seen. The performance has been awesome on Windows 8 for them. So the canvas itself is going to be a single tag, and I want you to think of canvas as, close to the metal. Don't think of it as a framework, like much the way that XNA was. Think of it as that underlying way of writing primitives. So if I go in here, this is the API. You're going to see ways to do fills and strokes and rotations. You're going to see the ability to do paths and primitive shapes like rectangles and all of that kind of stuff. So the good news is that the community has really wrapped stuff around this. So if we go, and this will be in the slides as well, this link. So I'm up on GitHub, and BEBRAW has a really good page that lists all of the HTML5 based game engines out there. So if you're coming from a Flash background, you're coming from an XNA background, people have been wrapping the HTML5 canvas tag into kind of a higher level framework. And there's frameworks out here that even have map editors. So I recommend going here as a way to figure out in your game. For my game, I just wrote a little custom game engine that you'll see, but you have the ability to pull in bits and pieces here, and you may even want to go ahead and add onto those projects and make them better so that we can all benefit. Now, when I instantiate a canvas tag, it's basically one HTML element. I'm going to say canvas, and then I'm going to close canvas. If you were doing this on the web, you would have some type of fallback, but obviously in a Windows 8 app, you know that it's going to be IE10 and IE10 all the time, so you can take advantage of all those HTML5 features without having to worry about things like polyfills. What I'm doing here is you can see the canvas tag, which I've called my canvas. I've given it a width and a height. And then I'm going to do some JavaScript. So just like web development, the DOM is a scary place. We don't want to keep accessing the DOM. We want to pull elements out of the DOM into the JavaScript world. And that's really where we're going to get that nice performance boost. So what you see here is a get element by ID. You could totally use jQuery or some other type of syntax to pull your own way of pulling your elements into the DOM. I'm pulling in my canvas and I'm giving it a canvas reference, and then you need to get a context. Currently that's only 2D for that canvas. And then I'm telling it inside of that context, I want to set the fill style to basically be red, and I want you to draw a rectangle at this X and Y coordinate with this length and height. And that's what you're seeing down here. You're basically seeing a red box. So just like the other tool that you saw for exploring through CSS3, we have a tool called Canvas Pad, which you can go up to the same site, i.e. Microsoft.com test drive, and this is a way in real time that you can really start learning the underlying Canvas APIs. So for example, you can see here, draw blue rectangle, and let me increase the size even a little bit more for everybody so they can see. You can see I have the blue rectangle over here, but maybe I don't want an RGB value. Maybe I just want to say red. And then I can go ahead and execute this, and you'll see the rectangle is now red. So it's that fast, it's going to go ahead and draw those pixels. Now I won't go through all these. We won't have time to go through every single one here. You can see there's different things like shadows and text and colors and different shapes. You get gradients and patterns. What I want to point out is, you know, this stuff is hardware accelerated. So what you're seeing here is you're actually seeing video being drawn as an image to the canvas. And to show that this is in real time, I could take the width of that, and maybe I'll say 100, and I'll go ahead and execute this, and now you can see the video is being drawn within that 100 space. So a very, very powerful API, and this is a way for you to load up and kind of explore around inside of there. Now, let's talk a little bit about the game loop. We know about the canvas tag. We know that's what we're going to write to. We know about CSS3 to do all of our layout and our stylings, and we know about some of the HTML5 features we can take advantage of. Let's actually write a game. So all games, whether you've written a game or not, you've probably seen this, is they have this basic pattern. So I'm going to go ahead when I boot up and I'm going to initialize my game engine, and that's going to load a bunch of resources that I'm going to use throughout the game. For my game, that happens to be different star fields, different planets and spaceships and things like that. And then what I'm going to do is I'm going to look for user input. So in the case of my game, that happens to be some type of touch. That could be a mouse, a stylus, it could be touch points on the screen, but the user is going to touch somewhere on the screen. And then I'm going to calculate those points that they touched against some type of test criteria. And for me, those test criteria are going to be the location of the spaceships. But obviously, you can get extremely fancy in any of your games, and this would be where your logic is. And then you're going to give feedback. You're going to go ahead and render to the screen, and you're going to kind of continue in this loop of getting user input, calculating against some test criteria, and then drawing to the screen. So the way that's been done in HTML5 games for a while was through a set interval call. So the way we would do this on the web is we would typically look for, for the DOM to be loaded, and we would call some type of init event. So this, basically be an onload event for your page. You tell it to call int, and then what you're seeing here is set interval, It's going to give it the function to call, and then we're going to give it a time period of how many frames per second we want. So this is in milliseconds, which is why you see the 1,000. I've got a variable up here of 30. So 1,000 divided by 30 would make sure that we call that that function, game loop, that many times per second. So in this instant, my game is running 30 frames per second. 30 times a second, it's going to update something and it's going to draw something. So it's like the old animation of flipping through a deck of cards. You're really doing something rapidly across a piece of time, which happens to be 30 times over 1 second, and then to the human eye, that looks like animation. Now, the good news is there's a new standard called request animation frame. And IE10 supports this, and of course, because IE10 supports this, you can use this in your Metro style app. So what we're going to do is we're going to use MS Request Animation Frame, which is the Microsoft implementation of that API. And what this actually does is it looks at the refresh rate of your monitor. So my monitor here is running at 60 frames a second. It's going to do its best job of getting you 60 frames per second in your game to match, and it's going to run on your GPU. So unlike set interval where it's on the CPU, this is going to make your game hardware accelerated. And I am not kidding when I say I've seen performance boosts of 70% or more. You definitely want to look at request animation frame. And this is a sample from my Space Cadet game. So what you can see here is 30 times or 60 times a second, I'm going through here, and if the menu was clicked, I'm going to draw the stars. Otherwise, I'm going to update my ships and draw my ships. And so I go update, draw 30 times a second. Now, I've thrown some of this in the slides if you want to take a look at some of the engines I mentioned up on GitHub, Easel.js. I've pulled some samples from XNA. I've seen people convert some of the XNA samples to HTML5. And then these are the IE test drive and make awesome websites that you can also check out. So let's look at how we implemented Canvas inside of our game. I'm going to go ahead and stop this. We're going to drop into the default HTML. And what you're going to see here is I've got a div tag. I just happen to call it div root. And then I have my canvas. And I called my canvas canvas. Now, you're also seeing a data dash attribute here. This is a W3 standard. So if I was to go ahead and render this div tag in a browser, it would still render. It just doesn't know what this is. And I'm going to get into WinJS a little bit better. But to give a heads up early on, a viewbox has the capability of stretching to fit what's ever inside of it. So in this case, it's going to go ahead and stretch the canvas for us. Now, let's go ahead into the default JavaScript. And what you're going to see is just like an onload event in the web, we've got a DOM content loaded event. Now, DOM content loaded in Metro style apps basically means I can access everything in the DOM. It doesn't mean that maybe my images are fully rendered, but programmatically I do have access to those objects. So this is the event I'm going to listen for, and then I'm going to call my initialize function. So we'll come over here. Inside of initialize, you will see that familiar tag of canvas get element by ID, and I'm going to set the 2D context. Now, what I actually do here is I'm going to set up the coordinate system for my game and adjust the size of my canvas on the resolution at runtime. So what you're seeing here is a bunch of variables. So if I'm using it like a constant, where you'll see full screen width, I have it up here at the top, and I've tried to comment what each of those values were. So I'm assuming 1368, 66 by 768 as the default, and then that will change. And I'm setting my width and height of ships, so I know the bounds of being able to hit, I know is 190 pixels wide by 100 high. I'm setting the speeds of the different ships. I'm setting different things for my game of, how many points are required for gravity pulse, how much do the ships, how much faster do they go each time you get a new level, all of those type of things. Now, what we're going to do here is we're going to set the width and the height of the canvas to whatever the size of the window is. And you may be saying to yourself, wow, Dave, how am I going to test across all of these devices? So Microsoft has included a simulator where even if you're on the smallest machine, you can see what it looks like if you're running on a much bigger screen. So you can see here a simulator. I'm going to go ahead and run against the simulator now. And simulator is very neat. It's actually my computer virtualized. So if you've ever seen the movie Inception, it gets a little strange, and you're going to see your own app here. You could load stuff in here, and your PC within your PC within your PC. But if I come over here to the right, you're going to see change resolution. So you're noticing this is simulating a 10-inch tablet, which is running at 1366 by 768. You also notice we've got these higher resolutions here. So, these what would be high density displays. Sometimes you hear these referred to as retina displays. What does my app actually look like inside of those resolutions? So this is where you'd want to include higher resolution clip art, and you can test that out here. I could also test out what does it look like on a 23-inch monitor and a 27-inch monitor. So because this is recording 1366 by 768, we've got the debugger open from before. So let's go ahead and pull the canvas height and width, and you'll notice now, rather than being 1280 by 960, which is what we're recording at, you see that 1366 by 768 value. So our game system has now adjusted itself to those new screen widths and height. And then my max X and Y, if we come over here, you'll see 1156 is the farthest that my ship can go on the screen, and then 618 is the farthest that it can go high. And that's so I'm giving a little bit of buffer around the ship. Once it goes to that side, it's going to disappear, and then a new random ship is going to be drawn. What's also neat is if we go ahead and we continue to run this game, if you've used the developer debug tools inside of IE, you get that same DOM Explorer here in Visual Studio. So I can click on DOM Explorer, and you may miss it, but there is a Select Element button here. If we hit Select Element, I can come right down here to my button, and then I hit on this button, you'll see I can actually look at the HTML for that button. I can see the events on my button, so for example, I have a click event, and it calls a function called Start Game inside default.js. And we've got different styles that you can see here. We can also trace through those styles. I can look at my layout, so that's at 311 by 535 pixels, and then I can see all of my attributes. So very, very unique way of going through your app and actually seeing all of your styling in there. Let's go ahead and close the simulator, and we'll jump back. So Canvas and Game Loop, we've got CSS3, we've got HTML5. Hopefully you're feeling a little bit excited now of, hey, you know what, I might actually be able to do this. And I think you can bring some really good retro games, in my case is what I'm planning on bringing to the store, using all this. So the next piece, obviously, for your games, if you've got a game engine running, you got all your layout, you want to look at how the user is going to interact. So let's look at touch. And when I say Windows 8 is a touch-first OS, that doesn't mean that you have to always be constantly thinking of tablets. What it does mean is if you're writing a game and you're testing that out with your mouse, you need to be thinking about some of your customers are going to be using a finger. And your hit targets need to take that into effect. So a mouse is a very precise instrument, but a finger is very, very different in the size, and I think you'd be surprised how big your hit targets need to be. So really think about that. Think of it as a touch-first OS. How are people going to integrate with my game? And then the next piece is we unify all of those touch points for you. So whether it's a mouse, a pen, a whole bunch of fingers, or a single finger, all of that is going to be unified under these pointer events. And typically what you're going to see here, you're going to integrate with these events on the left. So I'm going to have pointer down, I'm going to have pointer up, I'm going to have the ability to hover, so if I move my mouse over that button, or in the case, move my finger over that button, I'm going to get the position for where that touch is happening, as well as if it was from touch, mouse, or pen. So to make this real, let's go ahead and look at the Space Cadet demo. And what we're going to do is, let's look in the init for our event listener. So you'll notice I'm adding an event listener to the canvas. So wherever you want to listen to that touch event, which is MS pointer up, you have to add an event listener. So, I could have a game where my canvas is only part of that screen. Maybe I have a side screen that has information, settings, other things like that where I'm not necessarily looking to handle the same type of touch events. For this example, I have Canvas as my entire game screen. So I'm looking for the pointer up. So this is after they remove the finger. So they could put the finger down on the screen and drag it across. It won't register the X and Y coordinates until they let go. So it'll be wherever they let go. Or a mouse click, same exact thing. So I have a function I call touch handler. and you'll see I get an event. And that event has an X and Y coordinate. And that's it. It doesn't matter if it's a pen, a mouse, or any of the fingers. You're going to get the exact X and Y coordinate that you need. And so this would be the center. In the case of a finger, this would be the center of where that was touched. And what I'm doing here is I'm looping through an array of ships I have, and I'm calling ship hit based on the X and Y coordinate of that ship, and I'm seeing if it matches X and Y for that event. And to show you what ship hit is, you can see right here I'm looking at the maximum width and height of those ships. And again, this was all based off of our initial settings for how big I wanted the ships to be, as well as the coordinate system we based on how big the screen is. Now, the ships themselves, if you look over here, you're going to see ship.js. So ship.js, I've just created a standard function. I'm going to go ahead and pass in some values of the max X and Y coordinates and the acceleration. Level multiply is basically every time there's a new level, how much do I want the speed to increase. And then that's it. You can see I'm just got regular JavaScript here for setting the source of the image, for doing some random coordinates for X and Y, and those images are just an array that we go through. That's it for touch. Now let's look at camera. Now, camera could be built into a laptop. It could be, part of the Slate device. It could also be a webcam. So I'm actually on a desktop here. So this is a Microsoft LifeCam that I'm using. All of that in the past, if you have done Windows development, you would have had to probably wrap some comm calls, and you would have had to figure out how to actually access that device. If you've done Windows Phone development, we have something we call tasks, and it was the same way in Silverlight. You really had this media namespace, and that wraps around all that hard functionality for you. All you care about is capturing a photo or a stream. So you've got two options inside of this API. The first, which is the one that I've used, is called Camera Capture UI. Now, Camera Capture UI will give you a default UI for doing camera settings, for taking a picture, for trimming photos, and doing all of those. If you'd prefer to kind of create what the user is seeing and you have control over every pixel, you can also do that through the Media Capture API. Now, this is where we need to talk about capabilities, because if you've never done Metro style development before, one of the things that I think users are really going to love is when you install a Windows Metro style app from the Windows Store, you know the capabilities of that app. Not only has it been certified by Microsoft, but it lists out what it wants access to. So no app will ever try and access your webcam without declaring it had intent for that on the web store. And the way we set that in our own app, so I'll show you inside of Space Cadet, is we've got a file here called our app manifest file. So you see package app manifest. I can go ahead and I can double click on that. It'll open up the editor, and you're going to see capabilities. And down here at the bottom is webcam. So if you're trying to access the webcam in your own app and you didn't have this checked, you're going to get an error of access denied, and you're going to be scratching your head. Don't worry about it. It's kind of the initiation. When you're first writing Metro style apps, everybody forgets about this capabilities, and then it becomes old hat as you move along. These capabilities map one-to-one to the capabilities that you'll see on the store. So for example, if I go ahead and open up the Windows Store and I click on a game, so let's do Cut the Rope, you can see what this app has permission to right down here. Does everybody see? Internet connection. So webcam would be listed there as well, and it allows the user to feel safe about the app that they're actually installing. Now, if we're going to go ahead and take a photo, we obviously need to set an image of where we're going to store the photo. So this is just a little piece of HTML. I'm going to create an image tag I call image display. And then I'm going to make a call into the Camera Capture UI. So this is the WinRT API here. And then I'm going to call Capture File Async. It's important to remember inside of the Windows runtime, everything runs asynchronous now. So this call is not going to block our app. It's going to actually go out, and we're going to tell it to be in the photo mode. If I wanted to take a video, it would be as simple as mode.video. And then, so this is JavaScript promises. So if you've come from the C# world, you're going to see things like await. Inside of the JavaScript world, we're looking at then. So when this thing comes back, then I want you to go ahead and call this function with the captured item. And inside of this function, if I actually have something, go ahead and set the source of that image display to that captured item. Now, URL create object URL is just another web standard for doing file paths to items. So this will figure out what that file path is for you. To show you what that looks like in our little Space Cadet game, let's go ahead and open up default.js. Actually, let me take one step back and show you. We have this command in our app bar called command camera. And so command camera is the button where we actually fire off the camera. So let's go command camera. You can see here, I get that element and I tell it on the click event, I want to call capture photo. So we'll go to capture photo. I'm going to create what a variable I'm calling dialog for Windows Media Capture, Camera Capture UI. I'm setting an aspect ratio. So this is the cropped aspect ratio. What's nice about this is when the user goes to crop a photo, they can't make any size square that they want. That square is going to be locked to this aspect ratio, and I'll show you that in a little bit. And then this is the same exact code that you saw on the slide. So when I get something back, I'm going to actually set my image player source to that file. And just as a refresher, image player, if you recall, was right up here, next to a player name, a score, and a level. So you can see image player, source, and I use a default helmet. So if we go ahead and run this, let's run this thing locally.